Global warming reduction using nanomachine. A project done by Shiva Kumar under the guidance of Sharma, Department of Nanoscience and Technology, Anna University of Technology, Tiruchi. The Earth's atmosphere is classified as several layers. For example, stratosphere, troposphere. Troposphere is the first layer, stratosphere is the next layer. During the Industrial Revolution period, more amount of carbon dioxide gas is pumped as exhaust by vehicles that uses gasoline and other petroleum products. While in daytime, part of the Earth is exposed to sun. Earth absorbs more amount of energy as solar radiation during daytime. Further, what has been absorbed should be given off. Earth emits the absorbed solar radiation as infrared waves during nighttime. The greenhouse gas, carbon dioxide, has the property to reflect the infrared radiation. Especially this property is needed to maintain the Earth's temperature as constant during nighttime. Due to abnormal increase of carbon dioxide levels in atmosphere, whatever the energy comes in will be trapped inside and increase the temperature of Earth day by day. Our work is to design a nanomachine and put over the atmosphere so that it will replicate by absorbing carbon dioxide gas molecules and convert them into carbon and oxygen. The carbon is used as a raw material for constructing the basic building blocks of future replica of nanomachine. The nanomachine continue its replication exponentially so that amount of atmospheric carbon dioxide molecules will be decreased. We calculated that the replicating nanomachines can convert all the problematic carbon dioxide molecule into nanomachine in its 106th generation. The entire process can be controlled by a central supercomputer that has data from all the replicating nanomachines about density of a particular gas, also pressure and temperature of that place. This results in global temperature maintenance, or otherwise we can call it as global cooling.
This is the structure of our nanomachine. As seen, the filtered carbon dioxide molecule reached the nanogear system, whereby it has been chemically pulled or pushed by suitable gear tip functionalization. Now you seen is the model of nanogear system that ultimately break the carbon dioxide molecule. Based on molecular dynamics force field approach, the nanogear shows stability even at 10 billion rotations per second. This arranged nanogears upon rotation of 10 GHz can raise the temperature of the carbon dioxide molecule even up to 16,000 Kelvin. We measured temperature of the atoms in the molecular nanogear system based on simulation. At the same time, the gear tips hinging the molecule only raised to a temperature of 700 Kelvin. From this we tend to know even at high speeds, the gear tips shows strong stability. For suitable gear tip selection, we further refine our interest towards hinging molecules based on quantum mechanical simulations. We analyzed following tips using density functional theories: methyl, ethyl, oxygen and lithium gear tip. Methyl gear tips often tend to form bond between oxygen of carbon dioxide with carbon of methyl group upon hinging. Ethyl gear also shows similar property upon hinging. The partially water also formed. Lithium gear tip shows better carbon dioxide bond breaking ability by elongating it above 140 picometer between carbon and oxygen. In future, synthesis of nanostructures using random chemical routes may not be sufficient. At that time, computers can read the molecular model data and construct its own production plan. Further gave those plan-based orders to the assembling tools that use mechanostatic type that can place arms in mechano-dynamic type breaking. This is what we call nano-CAD-CAM interface as shown. One of our co-project called nanolinux is getting wide response from various countries. We are also noted in local dailies also. Actually, nanolinux is an initiation towards an open-source computing platform that has all the software tools that are needed by a nanotechnologist, so that the already created nano divide between the individuals who has tools and who has not can be minimized.